All right, folks, I'm still getting a lot of questions about the tail of Comet C2014E2 and whether it brushed Venus during the downtime for stereo head HI2. You can see the comet in the dramatically contrast enhanced version here and the lens flare previously discussed. But now the question mainly seems to be about the tail and it brushing Venus or not brushing Venus. And some are claiming I was deceptive or lying in my last video about that. No, I wasn't, but we'll take a look at that in a second. First, let's see what's being said.
The main thing I want to show here is so when Astro goes to debunk the Venus being brushed up by Jacques thingy, he shows this orbital Jacques. Like, oh, look, it's 3D, man. And see, in 3D, it doesn't come anywhere close. And then if we look at his orbital, it like ends somewhere around Jupiter, right? You know, it goes around mixed loop around like Jupiter and then comes back down. And it's like, what orbital are you using, man?
Okay, so he asks, what orbit am I using for the comet? Well, I'm just using the standard official orbit for the comet in Starry Night Pro. You can download the data automatically, update the data files, and it will go and download that. But you can take it from there. You can actually look at the orbital elements for yourself and even change them within the program very easily. And when you bring that window up, it also shows you a diagram of the orbit in relation to the solar system. And you have to zoom way in to see the orbits of the planets. Got Mercury, Venus, and Earth here. So obviously, the orbit goes out a lot farther than Jupiter. In fact, if I take a look here at an overhead view and zoom out from the sun more, you can see that indeed this is a long period comet. It goes out there way past the orbits of the planets. And that's using the same orbital data I had in the previous video. You can see the same thing from that perspective, kind of zoomed out behind Venus, looking at the situation. So you can see stereo head looking towards the comet and Venus in the HI2 camera, but from that two-dimensional perspective, you can't necessarily tell that the comet's actually much closer to the spacecraft than Venus is. We also have some fisheye distortion because I have such a wide field of view here set that you get this sort of fisheye distortion effect that can kind of warp the appearance of the orbit a little bit, and that might lead to some misunderstanding as well. But we can actually look at the orbital elements, and we can make sure that they are the true orbital elements of the comet. Again, save. Again, if you look at the three-dimensional orientation here and what's going on geometrically, the tail of the comet is pointing away from the sun. And at the time that the comet has reached the same ecliptical longitude as Venus, it's well above the orbital plane of Venus. So the tail of the comet does not intersect Venus. It just doesn't happen. The geometry isn't right for it. But, you know, maybe the official orbit is somehow a conspiracy to hide that fact. Maybe it really did brush Venus and they covered it up and shut down the camera. And this is actually not where it was. It was actually way over here by Venus. It was brushing it with its tail. I don't know. So let's take a look at that and take a look at the orbital elements and see how they stack up against an amateur calculation of the orbit using purely amateur data. So let's take professional observatories. Let's take NASA out of it and only use amateur observations of the comet to calculate the orbit. And if we do that, this is the solution we get. I didn't even use all amateur data. I just used primarily amateurs who use itelescope.net. Most of those observations come from, in fact, really all those observations come from the Siding Spring Observatory in Australia and their New Mexico site. I also included some observations from another amateur in Arkansas, but primarily it's itelescope.net data, and you can go online, you can rent those telescopes, and you can collect the same data yourself. You can collect your own astrometric observations using the same exact telescopes. you see being used here. Everything with an X is excluded. So this is just using 170 amateur observations spanning from March 13th to May 23rd. And doing that, we get amateur determination of the orbit. And here are the orbital elements. So we can plug these directly into Starry Night Pro and see what the orbit should look like, not according to professional astronomers, but just regular amateurs. So let's do that. Let's see here. Eccentricity. Let's just go down the line. So eccentricity is E here, 0.9991117. That's within a tiny fraction of the same eccentricity, and that's how it's going to be for all these orbital elements. They're going to be within fractions of a degree of what the professional determination is. So pericentric distance, that's little q. 663.9, that should be 1006. And again, this isn't even all amateur observations. If I, went through exhaustively and picked out every single amateur observer who had submitted observations, astrometric data, and plugged it all in, I'd get an even more accurate determination of the orbit. But for our purposes, this is good enough. Ascending node 56.39055. Argument at pericenter 344.04407. Inclination is 156.39253. Pericenter time, helium date is, perihelion will be at 256841. Yep, right day, point 0.016144. And the epoch of the observations, the epoch's a little bit different here. That's okay. Element epoch is going to be 24565.6871164. So that's right up here. And that's it. Okay. So we have now plugged in the amateur observations. I'm going to save those changes. And you can see there's basically no difference. It's the same thing. And this is from amateur observations. This is not from professional observatories. This is not from NASA. These are amateur astronomers submitting their observations of the comet, and it yields the same result. The comet does not brush its tail against Venus. The tail is pointing away from the sun, and it does not intersect Venus. So if I zoom in more, it'll actually render where the tail should be, just pointing away from the sun. And you can see it does not brush Venus. Zoom in more at that point because it's further away, so it stops rendering the tail. Really makes you zoom in more, but okay, you get the idea. It's not going to brush Venus. The geometry of the situation just does not allow that to happen. And that's that. So, once again, what orbit am I using? Well, it doesn't matter what orbit I use, whether I use professional data or amateur data. The answer is the same. And the orbit does not simply go to Jupiter. It goes well beyond Jupiter, well beyond the inner solar system. It is a long period comet, no doubt about it. And both amateur and professional data agree on that. Hope you have a nice day.